This is the homework video for lesson 4.4. We're in the textbook on page 206. So we're going to fill in the blanks. An equation is solved below. So here's all the steps that they did. We're just filling in the blanks. So to go from here to here, you notice that this x became a 4x and this negative 3x is gone. So what did they add to each side? So for x to become 4x, they would have had to add 3x. And if you add 3x to negative 3x, it goes away. So that's what they did. They added 3x. Letter B, to get from here to here, well, you notice the minus 4 went away and negative 7 became negative 3. That means they added 4 to each side. And then to get from here to here, they divided each side by, so to get x by itself, you divide by 4, and that's why it ended up down here. So the next blank is 4. Okay, number 3, to solve this, what can you add to both sides so t is only on one side of the equation? So you can either get rid of the 10t or you can get rid of the 4t. Either way, you're going to need a negative. Ideally, you get rid of the smaller one, but you can solve it both ways. And so you do have two options here. So for letter A, you could add negative 4t or you could add negative 10t. Either one's fine. And B, now they want you to solve the equation. So we've got t on both sides. Ideally, you want to get rid of this one. So we're going to minus 4t, same as adding negative 4t. So that goes away. We have 7. So we're going to have 6t plus 5, minus 5 from both sides. And 6t equals 2, and divide by 6. And 2 divided by 6, be careful, that's not 3, that's 6 divided by 2. So 2 divided by 6 is a nasty decimal, 0.3 repeated, which we're starting to learn and hopefully know is 1/3, but you can simplify 2 over 6. Divide by 2, and you end up with 1/3. Okay, number 4. First, they want you to solve this by adding negative 5x to both sides. Then we're going to do it with negative 3x to both sides. And the point of that is to show you that when you first analyze these, there's not a right or wrong way to do it in terms of getting rid of 3x or getting rid of the 5x. You only want x on one side of the equation, so one of them's got to go. And you can do either one. And so that's the point of this question, is to show you that both will work and get you the same answer. So for the first one, for A, they want you to add negative 5x or minus 5x from both sides. So this goes away, leaving a negative 22. 3 minus 5x is negative 2x plus 18. Now you see, out of these two, 3x and 5x, when you get rid of the bigger one, you create a negative number. Not a problem, but you're more likely to make a mistake with the negative. So normally we get rid of the smaller of the two, but this is fine. We're going to minus 18. So we get negative 2x equals negative 40. Divide by negative 2. And x equals positive 20. Okay, so for B now, we're going back to the original equation. And now for B, they want you to solve it by adding negative 3x or minusing 3x from both sides, which ideally is what you would do in the first place. But you can see it didn't cause a problem up here to not do that. So now we get 2x minus 22. So after that first step now, we've got a positive x. Honestly, not that big a deal. But maybe you would have forgot to divide by a negative here or mess something up with that. So if we always create positives, it just makes our life easier. So we're going to add 22 to get rid of that. So the x is closer to b by itself, and we get 40. And now all positives, no real way to make a mistake. X equals 20 for both of them. All right. After number 4, we went to 7. And for 7 and 8, I asked you to do checks, so we'll do those. 4k plus 39 equals 7k plus 6. All right, so I have k on both sides. I'm going to minus the smaller one, so minus 4k. 3k plus 6, minus 6 from both sides. I'm going to get 33 equals 3k. Divide by 3. K equals 11. Now, how do we do a check for these? You go back to the original just like always, and you plug your answer in. On both sides, anywhere you see it. And now when you do this check, you keep both sides separate, and you just want to make sure you get the same number on both sides. So I'm going to get 44 plus 39 equals 77 plus 6. So 40 plus 30 is 70. 9 plus 4 is 13. 70 and 13 together is 83. And 77 plus 6 is 83. So both sides come out equal. My check works, which means k equals 11 works. Okay, number 8. We take a look at this one. This is an instance where we wouldn't want to necessarily get rid of the 9n no matter what, because then we'd have nothing left on this side. It's okay, you can put a 0 there and make it work, but ideally you always want to get rid of this one then so that both sides still have something. In this case, negative 6n is the smaller of the two anyway, so that's what we would have done regardless, but it's just good to keep going back and thinking about those situations because they're going to come up. So we're going to get 15n equals 5. We're going to divide by 15. Now, it's not 3. It's not 15 divided by 5. It's 5 divided by 15. You get that 0.3 repeated again if you do that in your calculator. Simplify this, divide them both by 5, or do it in your calculator, and n equals 1/3. Okay, so now we have to do a check with 1/3. It might freak you out a little bit. So we're plugging in 1/3, negative 6 times 1/3 plus 5. So what's nice about the 1/3 is it's like dividing by 3, because you would put this over 1 technically. You multiply on the top, you get 9. Multiply on the bottom, you get 3. 9 divided by 3 is 3. Multiply on the top, get negative 6. Multiply on the bottom and get 3. Negative 6 divided by negative 3 is negative 2 plus 5. And so 3 equals 3, and our 1/3 is good. All right, no more checks. Now we're just going to fly through these equations. Y on both sides, get rid of the smaller of the two. Leaves you negative 1. Because I got rid of the smaller one, I have a positive coefficient here. So 6y equals negative 6, divide by 6, and y equals negative 1. Okay, out of these two p's, one on each side of the equals sign. Negative 8 is smaller, so I'm going to add 8p to clear it out. Negatives you add. So I have 46 equals 19. This is a 1p plus an 8p, so that's 9p. Now isolate it, so minus 19, leaving you just 9p. And that would be 27 divided by 9. And p equals 3. Okay, number 11. M on both sides, both negative. The smaller of the two is negative 3 compared to negative 1, so I'm going to add 3m. Again, you won't get it wrong if you do it the other way, but this creates positive numbers. Negative 1 plus 3 is 2, positive 2. And now I want to isolate that m. So 2m equals, that's a 7, so 1. Divide by 2. 1 doesn't divide by 2, so we leave it as 1/2. Number 12. Got some decimals here. All right, t on both sides. This would be the smaller of the two, so we're going to go minus the 1.5t, which gets rid of it, leaving me negative 2.85. I'm going to grab my calculator to make this easier. 8.4 minus 1.55. Get 6.85 t. And I'm not going to let the decimals bother me. Here's the t I'm trying to get rid of, so I'm going to minus the 10.85 to get it out of here. So this goes away. I still have 6.85 t, negative 2.85 minus 10.85. Let's be negative 13.7. And now I'm dividing to get t by itself. And I get negative 2. So this one, you can see I have multiple variables on the same side. So first thing I'm going to do is simplify. Now you technically don't have to do that. You can start subtracting things from both sides. And one thing I would see if you're starting to get really good at seeing this is a 7D and this is a 7D. So you could actually subtract 7D from both sides and it all goes away. But just to keep things consistent, I'm going to go ahead and simplify. So keeping the sides separate, combining like terms, this is a 7D plus 5, and this is a 13D plus 8. Now looking at the two variables, 7 is smaller, so I'm going to minus the 7. Leaving me 5. 6D plus 8 minus 8. I get negative 3. Divide by 6. And again, that stays as a fraction. So D equals negative 1/2. Again, some simplifying to do here. So we're going to distribute and get rid of parentheses. So that's 4x minus 16. That's 5x minus 15 minus 4x from both sides. So negative 16 equals x minus 15. Going to add 15. And so x equals 1. Negative 1. All right, 15. Now we're going to have to come up with the equations ourselves. So Nebraska's population has been increasing at a rate of 13,300 per year. So that's going to get attached to the variable times years and reached this much in 2000. West Virginia is increasing at this rate and reached this in 2000. So those are going to be the two starting points. If rates of increase do not change, when will the populations be equal? So we're going to write an expression for Nebraska and one for West Virginia, and we want to know when are they equal, so we're going to set them equal to each other. So starting with Nebraska, I'm going to start with the big number that they're at, 1,711,000, increasing by 13,300 per year. And I'm going to want to know, when does that equal the other one? The other one started at 1,808,000, and it is increasing by 1,400 per year. So this one starts bigger, but it's increasing by much less. So eventually it's going to get caught. And now this is per year. I'm going to put, did they give me a variable? No. So I'm going to use y for years. Starting with this much, 13,300 per year. Started with this much, 1,400 per year. So looking at those two, the smaller of the two, if I'm going to solve this, is the 1,400. So I'm going to subtract that from both sides. It gets rid of it. So now I just have this. And over here, 13,300 minus 1,400 is 11,900. I still have all this out here. And because I got rid of the smaller one, I have a positive number here, so that's good. Now I want to get that y by itself, so I'm going to go ahead and get rid of this big number. So that leaves me 11,900 y on this side, starting to look a lot cleaner. going to do the subtraction here. Okay, and now I'm going to divide to get rid of this. Okay, and here's the answer that I get. And so that's not a beautiful answer, but it's asking how many years it's going to be. And so we're going to kind of round this, and we're going to say about 8.15 years. We're going to use that word about because it's not exact, round it off a little bit. But in general, for this question, a little more than 8 years is a good answer to that question. Okay, 16. 2000, so that's the year, don't use that number. Population in Dallas was this, and it's been increasing at this rate. In Philadelphia, the population was this and decreasing, so minus by this. Each year, that's the rate. All right, we want to know when are they the same. So we're going to write our two expressions and set them equal to each other. So starting with Dallas, 1189000, increasing, so plus 21,500 per year. When is that going to equal Philadelphia, which started much bigger? And it's decreasing by 6,500 per year. So when I look at these two y's, I have a y on both sides. I've got this, so I'm going to add 6,500y because it's the smaller of the two. So I still have this. Okay, this gets added 21,500 plus 6,500. That's 28,000y. And now I've got a single y. It's not on both sides, so I'm going to start trying to get rid of everything else around it. Okay, those go away, leaving me 28,000y. And then I'm going to divide by 28,000 to get rid of it. Okay, so it's 11.75 years later, and if you want to be exact, it's the year 2000 when this started, so 11 years later, it's the year 2011, and 0.75, that's 3/4 of the year. You could actually figure out that that's September, and so this is September of 2011. But you don't have to go that far. We're good with this. All right. Let's start a fresh page here. So after 16, we got 2 more questions. We're going to go to 19. So we're talking about some swimmers for their 100-meter times. The women's winning time was this, and it's been decreasing by this much per year. That's the record. So it's been going down, been broken every year. And then the men's winning time used to be this, and now it's getting broken and going down this much. So similar to what we just did, we're going to write an expression for each one. So letter A, they want you to just write it for the women's time. So we're going to have 53.84, and we're minusing 0.32 per year. And they want you to use X for years, which is kind of goofy, but that's what they want. So we're going to use X. Part B, do the same thing for the men's time. So 48.17, going down by 0.18. Again, X for years, that's what they wanted. And then letter C, About how many years will the winning times be the same? So when do these create the same number? So we're going to set them equal to each other. When are they the same? When are they equal? There's our equation. Now we just have to solve it. Out of these two, the smaller is here, so I'm going to add that one. Again, if you chose the other one, you'll still get the right answer as long as you take care of your negatives. So negative 0.18 plus 0.32. I get positive because I decided to get rid of the smaller, 0.14x. I have now simplified this enough where there's just an x on one side, so now we're going to isolate it. Getting rid of this. So 53.84 minus 48.17. 5.67. We're going to divide by 0.14. And you get 40.5. The question says how many years? After 40 years. You could say 40.5 years is fine as well. But it'll be after 40 years. Not before 40, but after 40.5. So after 40 years. And last question. Number 20. Some geometry here. So referring to these, the perimeter of the triangle is equal to the perimeter of the square. So that is adding up all the sides. So if we add all these up, let's simplify that. So just put your x's together. 2 and 4 is 6, plus 3 is a 9x. 3 and 7 is 10, plus 2 is 12. So why did I add them all up? Because I'm talking about perimeter. They said the perimeter, or the distance around the outside of the triangle, is equal to the perimeter of the square. So adding all these sides up equals the same number as if I add up all these sides. Now, because they only gave you one side here, a lot of people will just write 3x. But we got to be smarter than that. There's 4 sides, and it's a square. So all the sides are the same. So it's a 3x, a 3x, a 3x, and a 3x. Let's say 12x. Now, to solve this, smaller of the two is a 9x. Nice and easy. Just a reminder, if the smaller was one over here, you probably don't want to get rid of it and clear out that side. You can, but you got to put a 0 in that place, and then you're going to end up moving stuff back there anyway. So to save yourself some time, always get rid of this side if this would clear out completely. In this case, it follows our rules of getting rid of the smaller one anyway, so it makes sense. And divide by 3, and x equals 4. And if you take a look at the answer key, it said 4 units. That would be incorrect. The answer key is actually wrong here. I remember this from last year. So when you solve this out, you get 4. So that's where the 4 came from in the answer key. But it says find the length of the side of the square. The length of the side of the square is equal to 3x. We just found out that x is 4, so 3 times 4. So the side of the square is actually 12 units. So that is a mistake in the book. Final answer, 12.